Hi, my name is Matthew Archibald.
I am Ryan Rand.
Hi, my name is JD.
My name is Ephraim Hale.
My name is Isaac Smith.
I'm Eric Poole.
And we are the BYU-Idaho ASME team for the IAM3D Challenge. This year, due to COVID, many of us are in different places.
Because of that, we actually built 2 drones of the same design.
We were tasked with creating a 3D printed racing drone that could repeatedly pick up a 1-inch cube, fly a racing course, and drop the cube off again. 5 laps and 5 cubes. Each of these cubes were 3D printed, and a ferromagnetic washer was glued on top. We wanted the drone to be as durable as possible while also minimizing weight. This led to an interesting challenge of design optimization and improving our 3D printing strategies.
Using SOLIDWORKS, we went through many iterations, starting from basic non-optimized designs and working our way to what we have today.
We have worked really hard and have come up with an awesome final design.
This is what we ended up with.
To pick up the cubes, we decided to use an electromagnet. In testing, it was shown to be the fastest and most reliable form of securing the cubes. We also liked the mechanical simplicity that it offered over the servo design we tried. With the electromagnet, there are no moving parts, and it can be operated with the simplest MOSFET circuit connected to the flight controller.
We designed the chassis with a curved funnel to direct the cubes into the position where the electromagnet could pick them up with ease. Furthermore, we designed it so support material was not necessary. This was done even with the challenge of the camera compartment. By carefully controlling the bridge settings, it was also designed so attaching the continuous rotating servos was both smooth and easy.
Although in a perfect world we would never have a break in our frame, we often found them in ours. This helped us to realize we needed a main body with replaceable arms. Once we had our arms, we started testing and developing them under pressure. We hammered through them across the room and used every method we could find to just try to destroy these arms. We did testing in the real world where we would fly and eventually pieces would break. When a piece broke, we would look at what broke on it and come up with ways to protect against a similar break in the future.
In our design, we decided to have 2 cameras, one at the front view while flying and one embedded inside the wheel chassis. We programmed the flight controller to allow for easy transition from one to the other. The front camera was attached via TPU mounting brackets that were slid over the frame's front standoffs. And the second camera was secured by sliding into a precisely sized chamber. Having the second camera allowed us to see the cubes from a better angle while driving and dramatically improved our ground maneuvering.
For the wheels of our drone, we used continuous rotation servo motors so we could have precise control over the direction our drone moves in while on the landing pad. We designed our wheels to have spokes in a spiral pattern so that when the drone drops, much of the energy is absorbed.
To control the wheels, we configured PWM outputs on the flight controller. These signals tell the servos how fast to spin, and it's based on a mix of the aileron and elevator inputs. Our video transmitter was secured using a flexible TPU mount. The cleverly placed overhangs were designed such that they would hold the video transmitter in place but not require supports to print. In conclusion, the IAM3D competition has been a phenomenal competition. Not only was it challenging, but it was fun too. This task really pushed our understanding of the design process as well as our 3D printing skills. We've worked really hard going from a basic non-optimized design to a formidable drone. Thank you so much to ASME and the IAM3D team for this opportunity. We learned a lot and we look forward to future competitions.